A new dawn breaks over humanity's interplanetary journey as the year 2100 heralds our boldest venture yet, the colonization of Titan, Saturn's largest moon. This is the story of the Titan Pioneer, a state-of-the-art spacecraft designed not merely to transport colonists, but to serve as a self-sustaining ark for a new chapter in human evolution. Its journey, from the launch pad on Earth to the icy, methane-rich surface of Titan, is an epic tale of scientific ingenuity, relentless human spirit, and the will to adapt and survive in environments once deemed uninhabitable. In the final hours of 2099, as Earth's bustling metropolises quieted for the impending launch, engineers, scientists, and dreamers alike gathered to witness the ignition of the Titan Pioneer. Propelled by advanced nuclear fusion engines and guided by decades of research on low-temperature biomes, the Pioneer's departure signified more than the start of a voyage. It was a declaration that humankind was ready to extend its reach beyond the cradle of Earth. At precisely on January 1, 2100, the Titan Pioneer lifted from a high Earth orbit facility. Its sleek, aerodynamic design combined resilient alloys with smart materials engineered to withstand extreme radiation and temperature fluctuations. During the initial phase, the ship's fusion drive gradually ramped up, reaching a cruising velocity of 0.05% the speed of light, a speed that, while modest compared to interstellar aspirations, was more than sufficient for a journey measured in months rather than years. For the first 15 days, the Pioneer accelerated steadily, employing a continuous 1G thrust phase to mimic Earth's gravitational pull. This artificial gravity was crucial not only for the comfort of the 2,400 souls aboard, but also to preserve their physical health during the extended transit. As the drive reached its designed output, the vessel executed a controlled roll maneuver to distribute G-forces evenly along the length of the habitat ring. With a diameter of 500 meters, the rotating section generated a sustainable 1G by spinning at a calculated 2.3 rotations per minute, a marvel of modern engineering derived from principles honed over decades of orbital habitation studies. During the acceleration phase, the crew initiated a series of tests on onboard bioreactors and life support systems. These systems, drawing on closed-loop recycling and advanced aeroponic farms, would ensure that fresh water and nutrient-rich food could be produced continuously. The ship's central core, housing critical databanks, medical facilities, and emergency supplies, remained isolated from the rotating habitat where family quarters, communal spaces, and laboratories thrived in a simulated environment that felt much like home. Once the Pioneer achieved its desired cruising speed, the fusion engines were throttled back to a sustainable burn, and the vessel settled into its coasting trajectory. With Earth receding behind them, the passengers, scientists, engineers, educators, and their families, set about adapting to life in a moving city. Social hubs and virtual reality theaters allowed for cultural exchange, while advanced genetic monitoring ensured that the human genome aboard remained robust and diverse. As weeks turned into months, the Pioneer transformed into a bustling microcosm of terrestrial society reimagined for space. The habitat ring, divided into modular sections, became a tapestry of diverse activities. In the research modules, biologists monitored the evolution of microbes in the closed-loop ecosystem, ensuring that every organism, from the simplest bacteria to engineered crops, remained beneficial for human consumption. The ship's environmental sensors continuously tracked changes in temperature, humidity, and radiation levels, adjusting internal parameters to maintain optimal living conditions. Daily life aboard the Pioneer was a careful balance of routine and discovery. Schools, medical facilities, and recreational centers dotted the habitat's inner circumference, each designed with modular flexibility to accommodate the dynamic nature of a population in transit. Family units were encouraged to form intergenerational bonds with a carefully planned reproduction schedule, ensuring genetic diversity without overwhelming the available resources. Every newborn, a symbol of hope and renewal, was celebrated with a ritual that involved sending a small token, a pebble carved with the Earth's ancient symbols, into the ship's communication stream, a poignant reminder of humanity's origins. Simultaneously, the onboard command center maintained a constant vigil over every aspect of the mission. Sophisticated tracking systems allowed the crew to monitor not only the Pioneer's trajectory but also the subtle effects of long-term space travel. Even at 0.05% of light speed, slight variances in the gravitational pull of intervening celestial bodies were calculated and corrected using an array of ion thrusters strategically embedded along the hull. These corrections ensured that the Pioneer's course remained true, a narrow path plotted meticulously from Earth to Titan. The population aboard the Pioneer was a microcosm of humanity's best qualities: cooperation, resilience, and a thirst for exploration. From the moment of launch, every individual understood that they were part of something greater than themselves, a living experiment in adaptation and survival. The ship's artificial intelligence system, affectionately known as Aurora, managed day-to-day operations while also acting as a repository for the cultural memories of the old world. Aurora's gentle, modulated voice reminded colonists of the significance of their mission during communal gatherings. "We leave behind a world of beauty and conflict to build a future in harmony with the cosmos." After nearly 6 months of transit, the Pioneer began its approach toward the outer realms of the solar system. Saturn, with its iconic rings and majestic presence, loomed in the distance as a symbol of both natural wonder and a strategic waypoint. As the spacecraft neared the gas giant, the onboard navigation team executed a series of orbital insertion maneuvers, carefully adjusting the Pioneer's trajectory to take advantage of Saturn's gravity for a controlled flyby. The gravitational assist not only conserved fuel but also provided the necessary vector change for a subsequent descent toward Titan. During this phase, the Pioneer's fusion engines briefly reignited to slow the vessel relative to Saturn's moving frame. Over the course of 12 days, a series of precision burns fine-tuned the approach trajectory, aligning the spacecraft with Titan's orbit. The onboard chronometers, synchronized with Earth's deep space communication satellites, tracked every fraction of a second, ensuring that the time spent in Saturn's gravitational field would not disrupt the delicate balance of onboard systems. As the Pioneer entered the outer orbit of Saturn, the view from the observation decks was nothing short of breathtaking. Swirling clouds and the hypnotic interplay of light and shadow across Saturn's rings created an ever-changing celestial panorama. For the passengers, these moments of silent wonder provided solace and a reminder of the vastness of space, a constant contrast to the meticulously controlled environment within the spacecraft. Once in Saturn's orbit, the Pioneer's trajectory shifted again. The ship's engines fired in a carefully choreographed sequence to break away from Saturn's dominant pull and set a course for Titan. During this interlude, the command center distributed detailed briefings about the conditions expected on Titan, temperatures plunging to minus 180 degrees Celsius, an atmosphere thick with nitrogen and methane, and a surface sculpted by ancient cryovolcanic activity. These briefings were not intended to intimidate, rather, they served to prepare the colonists for the challenges ahead. Every precaution had been taken, and every contingency planned, to ensure that the new world would be a cradle for humanity's next generation. The final phase of the Pioneer's journey was both the most critical and the most exhilarating. Titan, shrouded in a permanent orange haze, awaited below, a world both alien and strangely familiar. As the Pioneer entered Titan's upper atmosphere, its heat shields, crafted from newly developed cryo-ceramics, began to absorb the shock of atmospheric entry. Unlike the re-entry of a spacecraft returning to Earth, the descent to Titan was a slow, deliberate process, designed to minimize thermal and mechanical stress on both the vessel and its precious cargo. Over the course of 36 hours, the Pioneer's external sensors mapped the atmospheric composition of Titan in unprecedented detail. Engineers had long anticipated the challenges posed by the moon's dense, nitrogen-rich air and the presence of complex hydrocarbons. Accordingly, the spacecraft's deceleration burn was executed in 2 stages. First, to reduce speed from orbital velocity to a controlled descent rate, and second, to deploy a series of inflatable deceleration devices that increased atmospheric drag. These devices, reminiscent of high-tech parachutes, unfurled in brilliant hues against the orange sky, their surfaces patterned with reflective materials designed to scatter solar radiation. As the Pioneer descended, the Habitat module, the New Dawn lander, prepared for its autonomous landing sequence. Unlike the Pioneer's main body, which continued its orbit around Saturn for further studies, the New Dawn was engineered specifically for Titan's surface. Equipped with robust landing legs, heat-insulated walls, and an array of scientific instruments, the lander was a mobile research station and the seed of the future colony. The final touchdown was a moment of collective breath-holding aboard the Pioneer. Sensors confirmed that the New Dawn had landed in Titan's northern polar region, a location selected for its relative stability and proximity to large methane lakes. The lander's shock absorbers and active suspension system ensured that even the rugged, icy terrain would pose little threat to the delicate equipment inside. With the landing confirmed, the colonists, both aboard the Pioneer and on the lander, celebrated this monumental achievement, aware that this was the first step toward forging a new home on an alien world. The initial days on Titan were dedicated to establishing a secure and sustainable foothold. Autonomous rovers and robotic construction units, which had been dispatched ahead of the colonists, began setting up the perimeter of the colony. These rovers, equipped with high-resolution mapping sensors and thermal imagers, surveyed the area to identify natural resources and potential hazards. The primary objective was to create a network of interconnected modules that would serve as living quarters, research laboratories, power plants, and agricultural domes. Each habitat dome was constructed from a composite material capable of withstanding Titan's sub-zero temperatures and resisting the corrosive effects of atmospheric hydrocarbons. The domes were arranged in a modular layout, with each unit connected by pressurized tunnels that allowed colonists to move freely between them without the need for bulky spacesuits. Inside, the habitats were designed with soft ambient lighting and climate-controlled environments that simulated Earth-like conditions, a stark contrast to the alien world outside. The colony's energy needs were met by an innovative combination of nuclear fusion microreactors and solar collectors optimized for the weak, diffuse light that penetrated Titan's thick atmosphere. Advanced energy storage systems ensured that power was available round the clock, even during the long polar nights. In addition, methane extraction units tapped into the nearby lakes, converting the abundant hydrocarbon resource into fuel and feedstock for chemical processing plants. This integration of energy production and resource utilization allowed the colony to operate as a near-closed system, minimizing the need for resupply missions from Earth. Social infrastructure was built concurrently with the technical facilities. The colony's central hub, dubbed Haven 1, served as the nucleus of community life. Here, colonists gathered for daily briefings, scientific discussions, and cultural events. Educational programs emphasized both the heritage of Earth and the unique challenges and opportunities presented by life on Titan. In a series of carefully choreographed ceremonies, the first Titan-born infants were celebrated as symbols of humanity's determination to thrive, even in the most hostile corners of the solar system. As the colony expanded, population management became a critical concern. Genetic diversity was maintained through carefully regulated reproductive guidelines, and every new life was integrated into the community with a combination of cultural rituals and medical oversight. The colony's leadership, composed of seasoned scientists, engineers, and elected representatives, monitored the delicate balance between growth and sustainability. In weekly town hall meetings broadcast across the colony's secure network, the leaders explained every decision and planned for future expansions, ensuring that every colonist felt part of the mission to transform Titan into a livable world. Life on Titan was as much a study in resilience as it was a celebration of technological achievement. The moon's environment presented numerous challenges, most notably the extreme cold, the constant presence of organic chemicals, and the low surface gravity. only about 14% that of Earth. To counteract these hazards, every aspect of the colony was engineered with redundancy and flexibility in mind. Inside the pressurized domes, temperatures were maintained using geothermal heat pumps powered by the colony's fusion reactors. The design of the habitats featured double-walled insulation with an intervening vacuum layer, preventing heat loss and providing a buffer against Titan's frigid exterior. In the event of an emergency, backup heaters and portable life support units were stationed throughout the colony, ensuring that no one would be left vulnerable in the face of a sudden system failure. The low gravity on Titan, while advantageous for reducing structural loads, also posed long-term challenges for human physiology. To combat muscle atrophy and bone density loss, the colony instituted a rigorous daily exercise regimen for all residents. Innovative resistance training devices, many of which doubled as recreational equipment, were installed in communal gyms. Medical teams conducted regular health checkups, and genetic researchers tracked subtle changes in the colonists' physiology, working to develop countermeasures that would preserve strength and vitality over generations. Another significant challenge was the pervasive presence of methane and other hydrocarbons in the atmosphere. Although Titan's thick haze shielded the surface from harmful ultraviolet radiation, it also created a unique chemical environment. Scientists in the colony's laboratories worked tirelessly to understand the complex organic reactions taking place in Titan's atmosphere, using the data to refine the processes of synthetic biology. The breakthrough came with the development of a bioengineered enzyme capable of converting ambient methane into usable energy, a discovery that not only enhanced the colony's resource base, but also opened new avenues for research into extraterrestrial. Throughout these challenges, the spirit of ingenuity and adaptability prevailed. Every setback was met with a creative solution, and every problem became an opportunity for scientific discovery. The colonists celebrated small victories, a successfully grown crop of engineered algae, the first sustained power generation from methane reactors, and the opening of a new research wing dedicated to Titan's atmospheric chemistry. These successes were shared in community-wide broadcasts and documented in digital archives, each entry serving as both a record of progress and an inspiration for future generations. The unique environment and the shared experience of building a new society in an alien landscape fostered a culture that blended the best of Earth's traditions with innovations born of necessity. Art, music, and literature flourished in the domes of Haven 1, where creative minds found solace in the juxtaposition of ancient human lore and the futuristic challenges of Titan colonization. Local festivals celebrated milestones in the colony's development, each event a reminder of the sacrifices made and the triumphs achieved. One of the most anticipated celebrations was the Day of First Light, marking the anniversary of the New Dawn lander's successful touchdown on Titan. On this day, colonists gathered in communal halls, recited poetic tributes to the intrepid pioneers of old, and unveiled artistic installations that captured the surreal beauty of Titan's orange skies and methane lakes. Educational institutions on Titan integrated curricula that blended Earth's history with lessons in space survival, astrobiology, and sustainable engineering. Young colonists, many of whom had never set foot on Earth, learned about their ancestral home through virtual reality experiences that recreated the landscapes, sounds, and smells of long-gone cities and natural wonders. This fusion of the old and the new became the cornerstone of Titan's cultural identity, a dynamic society built on both memory and innovation. Religious and philosophical movements also evolved in this unique environment. Many colonists found meaning in the challenges they faced, viewing Titan not merely as a destination, but as a crucible for the human spirit. Debates and discussions in the communal forums often centered on the ethical implications of terraforming and the long-term stewardship of an alien ecosystem. While disagreements were inevitable, the shared goal of survival and progress ensured that these debates remained respectful and constructive. The social fabric of the colony was strengthened by an emphasis on cooperation and communal responsibility. Governance on Titan was decentralized yet united by a common vision. A vision of a future where humanity could thrive without the burdens of Earth's past conflicts. Regular assemblies and council meetings, held both in person and via holographic links, allowed every voice to be heard. The colony's leadership, elected by the residents, was held to rigorous standards of accountability, ensuring that decisions were made transparently and with the welfare of the community in mind. The colonization of Titan was not just an act of settlement, it was a leap into a new era of scientific exploration and technological advancement. The colony became a living laboratory, a place where the boundaries of biology, physics, and engineering were pushed to their limits. Research initiatives spanned a wide array of disciplines, from astrobiology and exoplanetary geology to advanced robotics and quantum communications. One of the most revolutionary projects undertaken on Titan was the development of a localized weather modification system. By harnessing the natural convection currents in Titan's dense atmosphere, scientists engineered a series of atmospheric modulators designed to regulate local climate conditions around the colony. These devices, though modest in scale, had a profound impact, stabilizing temperatures within the domes, reducing the impact of sudden methane storms, and ensuring that the delicate ecosystems within the agricultural modules could flourish. In tandem with these engineering feats, genetic research played a crucial role in adapting Earth-based flora and fauna to Titan's environment. By selectively modifying plant genomes to tolerate extreme cold and to utilize the available light spectrum, botanists created new strains of algae and small crops that became the backbone of the colony's food supply. These genetically enhanced organisms not only provided nutrition but also contributed to air purification and waste recycling, forming an integral part of the closed-loop ecosystem that was essential for long-term survival. Looking forward, the scientific community on Titan set its sights on even more ambitious projects. Plans were laid for the construction of an interdome transportation network, a system of high-speed maglev trains that would connect the various sectors of the colony. Moreover, the success of the Titan mission spurred discussions about further exploration of Saturn's other moons, hinting at the possibility of a broader human presence throughout the outer solar system. The achievements on Titan also had far-reaching implications for Earth. Data transmitted back via deep space communication relays provided new insights into sustainable living in extreme environments, a knowledge base that influenced environmental policy, urban planning, and energy management back on the home planet. In a way, Titan had become a proving ground for technologies that might one day be used to mitigate the impacts of climate change and resource scarcity on Earth. As the colony matured, the narrative of Titan evolved from one of survival to one of thriving. What had begun as a daring experiment in space colonization transformed into a vibrant community that embraced both its challenges and its potential. Every day, the people of Titan worked to transform a once forbidding alien landscape into a new home, a place where the human spirit could soar, even in the cold, dark expanse of space. The Titan Pioneer, now long past its role as the transport vessel, continued to orbit Saturn as a silent guardian and a reminder of the journey's beginning. Children born on Titan grew up with a sense of wonder about their unique world, learning early on that every sunrise over the methane lakes and every shimmering twilight on the ice fields was a testament to human ingenuity. The legacy of Earth was preserved in digital libraries, oral histories, and artistic expressions that celebrated both the origins and the destiny of a people unafraid to venture into the unknown. In quiet moments, as colonists gazed out through reinforced observation ports at Saturn's majestic rings or the distant glimmer of Earth's blue light, they reflected on the extraordinary journey that had brought them here. Their lives, once defined solely by the boundaries of their birth planet, were now interwoven with the vast tapestry of the solar system, a tapestry rich with challenges, triumphs, and the promise of future discovery. The lessons learned on Titan were many. Humanity had discovered that survival depended not only on technology, but on cooperation, adaptability, and an enduring commitment to learning from one's environment. The colony's success was a testament to the fact that even the most hostile worlds could be tamed with ingenuity and perseverance. Each milestone achieved, from the first sustainable crop yields to the successful deployment of advanced weather modulators, reinforced the belief that the future of our species was as boundless as the cosmos itself. Now, as the year 2100 unfolds and Titan's colony stands on the threshold of its next phase, the inhabitants of this new world look ahead with hope and determination. Plans for further expansion are already underway. Proposals for additional habitat domes, expanded scientific research centers, and even exploratory missions to other icy moons of Saturn. The colonists envision a future where Titan becomes not just a lone outpost but the nucleus of a network of human settlements throughout the outer solar system, a hub of innovation, culture, and sustainable living. The journey that began with a single launch is now evolving into an era of continuous exploration. Future generations will inherit a world that was forged in the crucible of space, where every challenge was met with a solution, and every hardship became an opportunity for growth. The colonization of Titan is not merely a technical achievement, it is a transformative experience that redefines what it means to be human. It is a story of dreams realized, of risks taken, and of a collective will that transcends the limits of gravity, time, and distance. As Titan's population grows and its infrastructure matures, the colony will serve as a beacon of hope for all of humanity. The lessons learned here, about resource management, environmental stewardship, and social harmony, will ripple back to Earth, inspiring a new era of collaboration between the two worlds. In classrooms on Earth and in the vibrant corridors of Haven 1, young minds are already imagining the next steps. Advanced terraforming projects, the creation of hybrid ecosystems, and even the possibility of interplanetary travel that will one day unite the farthest reaches of the solar system. The Titan colony stands as a monument to the enduring spirit of exploration and the belief that, even in the face of overwhelming challenges, human ingenuity can carve out a place among the stars. As the colonists prepare for another day on this icy world, they know that they are not just surviving, they are thriving, building a future that is as boundless and mysterious as the cosmos itself. In the fading light of Titan's long twilight, the colony of Haven 1 shimmers with life and possibility. Families gather in communal gardens beneath translucent domes where engineered flora glows softly against the backdrop of alien skies. Children laugh as they play in low-gravity fields, their voices echoing through corridors that once bore only the hum of machines. The colony's medical team reviews the latest health metrics, noting with satisfaction the steady improvement in bone density and muscle tone, a testament to the innovative exercise regimens that have become a cornerstone of Titan life. In the research labs, scientists pore over data streaming in from the lander's atmospheric probes, their excitement palpable as they uncover new details about Titan's meteorology and organic chemistry. Each discovery fuels the ambition to not only adapt to this new environment, but to master it, turning every challenge into an opportunity for growth and learning. The engineers too remain busy designing the next generation of habitat modules and refining the systems that make this fragile ecosystem sustainable. Back aboard the orbiting Titan Pioneer, a silent sentinel that once carried the hopes of thousands, the archives are updated with daily logs, personal memoirs, and messages of gratitude from those who call Titan home. In these records, the story of humanity's greatest adventure is being written in real time, a testament to the resilience and creativity of a species that dared to dream beyond the confines of Earth. As the sun of Saturn glints off the icy surface of Titan, a new chapter in human history unfolds. The colonists of Titan, with every heartbeat and every breath, embody the spirit of exploration. a spirit that has carried them across the void of space to a world that was once unreachable. They stand at the precipice of a future defined not by the limitations of their origins, but by the infinite possibilities of a universe waiting to be explored. And so, in the year 2100, as the cold winds of Titan whisper ancient secrets and the distant glow of Earth beckons from afar, humanity writes its next epic saga. A saga of survival, innovation, and hope. A saga that will echo through the cosmos for generations to come.